the core developer AMA, ask me anything. And you're probably better off if you're just asking about core development. Yeah. So we're, operators are standing by.
A billion calm operators are standing by.
Yeah, if you are the 99th caller, then you'll get a special mock t-shirt.
We could sign it.
Yeah. We need to start leaning into like the e-celeb angle of Urbit core development.
We'll start selling Joe's cigarette butts, use ashtrays. We could do some introductions while we wait for questions. I can go first. I'm Ted Blackman, rovnys-ricfer. I'm the CTO of the Urbit Foundation, and I've been working on Urbit core development since 2017. All right, who wants to go next?
I am palfun-foslup. I have been working with / on Urbit since about 2017. Been with Tlon Corporation since 2018. I started out in user space, making all kinds of contributions, but worked my way up into core development over time.
Go ahead, Joe.
Master-morzod, Joe Bryan. I don't know how you guys are picking the date at which you started working on Urbit. Is it like, I booted an Urbit in 2016. Does that count? Yeah, I've worked on most layers of Urbit in some capacity or another for 5 or 6 years. And recently joined the Urbit Foundation, was given the opportunity to pick my own title. So I am a senior principal staff engineer.
Very good.
Nice. Yeah, and I'm Philip Monk. I'm the CTO of the Tlon Corporation, and my first PR was in 2013. Worked on it mostly full time since 2014, and I do some of everything for sure.
All right. Well, we're starting to get some questions. So the first one.
Oh, go ahead.
You go for it.
There's a question here from Jack Fox I can answer super quickly. What's going on with Urbit native UI? So I spoke to Liam about that briefly today. We'll be having an extended interview with him on Thursday, I believe, a little later than the current time slot. I'll be interviewing him about it, but the last I heard from him was that he was rewriting the entire thing again, as he should. So that certainly sounds like progress.
Yeah, and I can say that he, it's under active development, and Liam just sent me a demo of a little Twitter app that I'd written with a UI auto-generated by native UI, and it was operational. So I've seen a few demos from him at this point. And Jack actually asked further. He said, I suppose for now, Goon is outside the scope of core dev. Goon is Liam's name for his native UI system. I wouldn't put that outside the scope of core dev exactly. It's pretty related. It's not in the kernel at the moment, and may never be, but it's it's a piece of systems programming for Urbit, so it's kind of foundational user space infrastructure, which is also something that we do as part of core dev. It's a little blurry, but yeah.
Yeah, the unique part about it is just that it isn't like you said, it isn't like a rewrite of something that exists already, for example. And so it's, on some level, not yet core dev, or not yet the responsibility of whoever's maintaining core dev or something like that, but it's certainly, intended to become.
Yep. All right, now we've got a few other ones. Will there ever be high-speed Urbit gaming? Who wants to take that one?
Well, that's kind
I
of
have my own answer to
loaded
this.
question, man.
Yeah. All right. Here's my answer here, and this may not be right, but the way I think of this is that computers are very fast. Urbit, as it stands, is significantly slower. Like it makes your computer a lot slower than if you weren't running Urbit. Now, as we've moved further in time, that factor has decreased. Like the amount that Urbit slows down your system keeps lessening. And there have been a bunch of performance improvements this year. If we use the remote scribe protocol and its descendants for more and more pieces of networking, then the bandwidth limitation that Urbit imposes will essentially go away. And we also need to do probably message-oriented arvo-var communication instead of packet-oriented to really get there, unless we figure out some tricks, and maybe we can get that to work at high speed. But in any case, and then there's also the Aries project, which is now being worked on as a joint effort between Zorp, UF, and Tlon. So that's ramping up, and once that lands, that could very well make Nock just no longer a slow language. We'll see exactly how far they get there, but certainly the sort of single core execution of Nock, we don't know where that ceiling is. It's much higher. We know it's much higher than where we are right now. People took JavaScript and made it go pretty fast. And so, I've always said that if you took the amount of money that's been dumped into making JavaScript go fast and dump it into making Nock go fast, Nock will go at least as fast as JavaScript, probably significantly faster. So I still believe that to be the case. And there's increasing amount of evidence for that given the successes so far of the Aries project. So we've got networking speeding up, right? Getting out of the way. We've got single core execution speeding up, getting out of the way. The Aries platform is also purports to be easier to parallelize for different operations, and there are a bunch of proposals around increasing parallelization. Even for numerical computation, if you express that in a single-threaded manner, but if you do it at a high level, and then you should be able to jet it with any kind of existing machine learning library, n-dimensional array library. I've been somewhat partial to the tinygrad library recently, but I think that's a bit higher level than some other ways that we could do that. In any case, there's been some effort put into that, but not very much so far. So even for big matrix math, it's not necessarily the case that Urbit has to impose any kind of scaling problem. So for a lot of and that's actually pretty related to what you might want to do for a video game where you're going to have a lot of graphics computation. So if all of those things, if Urbit can get out of the way well enough in all of those dimensions, then yeah, I think you could end up with pretty high speed gaming on Urbit. Now I think it'll probably, unless there are Nock chips that get built at some point, which also Winrux designed a Nock chip. It runs in simulation. It's not fully complete, but you can see it. It's a cool design. It is possible to build. But unless we have some Nock chips that are specially designed to run Urbit very quickly, I think that it's likely that Urbit will be slower for quite some time, slower than other forms of computing. And so now computers will continue to get faster, and the amount, the amount of sweat that your computer will need to break in order to run a video game keeps decreasing, unless you're going for the really big AAA titles. But it's much more common now to see video games written in interpreted languages, right? Like Unity uses C#, right? Like that's that can cover a much wider portion of the market than it could 20 years ago, because computers have gotten faster. So, there will always be people who need to push the envelope, and for them, I think pushing the envelope in knock is likely to only happen in a pretty far future. So that's sort of, I think, that's kind of AAA, high graphics video games are probably the last thing that get ported to Urbit. But I do actually think that they probably will be ported to Urbit eventually. All right, you guys think I'm full of it for saying that? What are your takes?
No, I think that's right. I think you'll see a whole progression of stuff that feels faster, and like you'll see real-time games much long before you'll see real-time graphics of the sort that exists in AAA games. You'll see that initially with the communication happening over, like, I don't know, WebRTC or something, and then at some point AIMS, but with relatively low traffic, and then just everything will eventually move in. I do think so. Yeah.
Yeah, that sounds right. It's definitely like the stuff Philip mentioned. Also, like, points to a question that came up in my mind when Backwiles asked this question. It's like, well, depends on your definition of what on Urbit is exactly. Like, it could be like all within Arvo, or it could be Arvo talking to some specialized external systems, right? And if you imagine, like, well, we want a laptop that runs Urbit as close to on the metal as it can next year, then what does that look like? And given the current state of things, like, there will still be some middleware there, but once you're in that position, you can start phasing that out over time and moving more stuff into Urbit proper.
Yeah, I'd just add that Ted pretty succinctly covered, roadmap and things that are a little more speculative than roadmap for performance improvements to most areas of the system. And the piece he didn't cover is the event log itself, right? So you have the obligation to durably record everything that happens to your ship formally, or the result of it, right? Which is to say, you can log the event, or you can take a snapshot of the state. And right now we do that in a very cautious way, and there are designs for improving that performance, but it will always be some kind of bottleneck in latency and responsiveness. And so that puts the onus on, the kind of question that Mark is alluding to, of what exactly is the nature of the integration of the game with Urbit. If it's your mouse movements and keyboard input and these kinds of things like that, can that be? I don't know what wall clock time is the floor for that to be responsive enough. I think that you can f-sync SSDs in 2 or 3 milliseconds these days, and you can get a pretty long way if you extract out all of the other costs of computation and say that we scale to infinity, everywhere else. That's still the bottleneck without some kind of batching or converting some kinds of IO into reads of the namespace, as we discussed, or things like that.
Well, the other thing you could potentially do, so one trend that I anticipate to start at some point, maybe once New Mars is out, I don't know, is that we'll see a lot more knock being run outside of the main event loop. And I think you could, I could definitely imagine a world where, like you looking around inside of a game by moving your mouse around, that it loads the game data by scrying it out, like it loads like the room, and moving your mouse around is actually something that happens just in knock without writing any events to disk, and it's only when you click something, you try to shoot someone that needs to go over the network or something like that hits the event log.
Right.
Yeah, that's also something that, if, let's say, Urbit gets big, and there's enough capital around to build an Urbit processor, I think you would put a little bit of non-volatile memory onto the die of the CPU, just enough to write 1 or 2 events, and that way you could have it persisted right there much more quickly than you would in a normal computer, because you could just prioritize that as part of the design. So I mean, I haven't built a processor, but I think you could do that. All right, let's go to the next question. Are there arms from Ben Brown? Are there arms of gall agents that are now redundant given solid state subscriptions? Will a gall agent look different in the future? I don't know about arms of gall agents being redundant, but my guess is that a gall agent will look substantially different in the future. And I'm not sure whether we're going to have subscriptions officially as part of the model, part of the application model. But I do think the application model will look a lot different. And the way that I've been thinking that we would like to take that lately is to establish a thin waist between the kernel space and user space, which would mean that there's basically like some kind of unifying ontology of what a user space application is. That's very simple. You can kind of describe in one sentence, and then have the details of that sort of be, there will inevitably be details there, but that having that thin waist could be something that allows people to reason about their user space applications more easily, ideally makes them more transparent, like more legible and transparent to the kernel, which may be at odds with the rest of this, actually, we'll see. And then the third thing is to make it easier to write an application that will survive across many updates to your kernel. And so this is something that Philip in particular has been thinking about a lot lately. And he wrote a very interesting essay about it called Step Nomadism, right? Was that the name of the essay? You just mentioned that.
I think so, yeah. I can link it in chat, I think.
Yeah. Do you want to talk about step nomadism a bit and that way of thinking about apps?
Yeah. Sorry, I just sent the link to you guys, so someone can put that in the YouTube chat. That'd be great. Yeah, the idea is basically, so a running app right now has its own formal state, the kind of state that you get in onload, and it's just a noun. But it also has a bunch of implicit state that is depending on the rest of the system. It's made these contracts, or we've called them leases sometimes, with the rest of the system and potentially with other ships even, where it's saying like, I request that you do this, and then I'm relying on you to respond to me. And if you don't ever respond to me, then I'm never going to make progress. And those are stored only implicitly in the rest of the system state, potentially even on other ships. And so this has been annoying in a number of cases, especially with respect to upgrades, because you have to upgrade not only the state that you have in your app, but also what, like, somehow still respond to or react to the responses you're going to get to requests that you don't even make anymore, but you made in a previous version. And the worst version of this is if you're suspended for a period of time, and then 6 months later, it's been several kelvins, a whole bunch of things have changed. Now you get woken up, and the only state you're given is the state that you explicitly saved, and you don't know what of those external IO leases you had on other systems, how many of those are still active. Surely some of them were probably thrown away, because they're not going to keep memory around for you forever. Like that, nobody can do that. And so, especially for an app that's suspended, your own ship's not even going to do it for an app that's suspended. Probably shouldn't really. And so what this suggests is that what we should actually do is, instead of saying your whole state is this one little noun, your whole state should be a noun, but it should be your formal state plus basically a list of outstanding IO that, you know, whatever things that you expect to come back from the outside. And then when you're revived, or maybe even on each upgrade, unclear, you're expected, like, you can assume that you're not going to get any of those old responses back, and you're expected to recreate any of those, any output, any subscriptions that you needed, any messages that you sent that you don't know if you maybe got an acknowledgement while you were out. You should try and resend them in a way that's safe, something like that. And so this puts somewhat more burden on the programmer, but it gives us this very nice property, which is that the entire state of your app is a noun. And you can suspend that, put it in a box, open it up anytime later, either immediately right after some big upgrade that changes a bunch of stuff, or 6 months later or 6 years later. And it should just run it, right? It'll look at what that data was. It'll convert it into what makes sense for that app nowadays, based on the updates to the app, convert it into what makes sense for the system nowadays, based on what updates happen to the system, and say, okay, now I know, you know, what I consider for this app, this to be a reasonable continuity of what it was doing before. And that system, I think, will make things a lot more resilient. It's fairly far from where we're at now, but it's not that far. And so I hope that we can move in that direction, in the coming years, basically.
Yeah, me too. Is there anything else that we want to discuss about this question here? Anything else that people want to bring up?
More specifically, most of the on-agent arm is about subscriptions, and so if you're able to avoid subscriptions and use only solid state subscriptions, then you probably won't have much there other than pokeax. But yeah, everything else should be pretty stable for now.
Cool. Actually, I'll mention briefly that there are some shrubbery proposals floating around. One from Hashtag Dibtux and another from Sarpin Laplux that were posted recently. And so those are proposals for more far-reaching changes to the application model that are based on scry maximalism. So dig around for those, ask those guys if they'll share them with you. I think there's still drafts, but people are thinking about it. All right, next question from Motful Winrux. I like this question. What is your least favorite part of the system and why?
That's a tough one.
I looked ahead, so I'm going to go first. My least favorite part of the system is jail, considered broadly. As I'm sure most people know, the Urbit ID system was originally informal, and then at the end of 2018, beginning of 2019, it went on the Ethereum chain as a set of smart contracts. And everyone knew that was temporary, or at least incomplete in some sense, right? If you just draw out the implications of Urbit being successful, the sort of naive smart contract-based approach would not be sufficient. Could not scale to keep up with it, barring incredible breakthroughs in those systems themselves. And this eventually became a real, but it did, I should speak to the advantages, right? It did make Urbit ID real in a way that it never was before. It made them truly sovereign, right? Owned, not just informally, but formally by their nominal owner. And made it possible to participate in marketplaces and all of these kinds of things. And it was a huge step. And then due to scaling problems and gas cost, it became a problem. And Philip built an L2 that actually runs in NOC, runs on your ship, and just uses the chain as a data storage layer. So all of this is very good. But what's not very good is the relationship of your ship to the third-party data source and the implications that that has for aims. Urbit by itself is actually quite resilient as a networking model and quite robust to changing network conditions. Its net traversal isn't as good as it could be, but it works very good on low-powered networks. It responds well in most cases to moving around. And there's a clear path to making that stuff better. But the dependency on getting data from the chain, which in practice means getting data from, these centralized gateways, because very few people run their own nodes. And then, at the very concrete level, the way that that data flows through the system, especially in the jail vein, and its horrible abuse of the namespace that we were just talking about recently, is, well, let's just say it's perfunctory. And it's one of, there's a handful of areas of problems that people tend to run into running Urbit in practice. And this, in my opinion, it's one of the biggest ones and one of the, I don't like it.
All right. I've got an answer. I hate the pretty printer. The Hoon pretty printer so if you type something in the dojo, some noun, some Hoon wing, or you ask it to run something and it didn't print out the result. And sometimes it's fine, but sometimes it just hangs. And I can't tell you how many times I thought I had accidentally written an infinite loop in some vein, but it turned out that actually I had just tried to print something. And I couldn't tell you exactly what it is that triggers the pretty printer to go into this hanging behavior versus not. So that's the thing that's caused me by far the most pain in all of my Urbit development.
I think for me, I'm very tempted to say it's air, but it's weird. I kind of have a...
This is like Gell-Mann amnesia, right? The part of the system that we actually work on is the part that we hate the most.
Yes. I have a love-hate relationship. It's like my, strange adopted bastard child, but it's also, this monstrosity of sorts. And it's, it's unfortunate. Like a web server in the present technology landscape is very much necessary. And so we include one, but also it's this absolutely enormous Earth protocol with huge truckloads of Earth implications that come with it, that we now have to deal with within the core, the kernel of Urbit. And so there's this constant ongoing battle of like, well, okay, we want to support all of the things that people reasonably want to do with an HTTP server on their their personal server, like weighing that against, no, we don't want to actually like explode the scope of this thing. And so, naturally what you end up doing, I'll be talking about this tomorrow, is you add more features to the thing, right? And, sometimes they're good, sometimes they're like, well, they're, sort of necessary constructs for all the baggage that not only HTTP, but also like browser behavior drags into the picture. A good example of this is the CORS, C-O-R-S functionality in Air, where what browsers often do for security reasons is send a pre-flight request asking about certain security properties of like, hey, I'm like on this origin, like that's different from you, and I want to be talking to you regardless. Like maybe you're using your Urbit as an external API, right? But then browsers, for security reasons, do this like handshake kind of protocol, and we can't. Like, I mean, we could tell application developers, like, yeah, whenever you do a web interface or like publicly, like over HTTP accessible API, you have to, implement this thing also. But we're not quite that cruel, and so we handle it for them within Air. but then Air is saddled with the burden of like tracking, well, which origins do we approve of, which ones do we reject. We need to track which ones have sent requests but aren't, haven't been approved or rejected by the user yet. It's like a little microcosm of why working with Air is frustrating for me.
Yeah, those are all good answers. The one that came to mind for me immediately is the Hoon compiler. Not because like I like Hoon as a language with some warts, but I don't think there's any other part of the system that's been as sort of intransigent, like as hard to improve. I still believe it's possible, and certainly we've made significant improvements, but it has issues along two dimensions, right? Number one, changes to the language itself, I think, really should be made at some point, especially surrounding the type system, especially surrounding polymorphism. I think that wet gates need to be replaced. And it's been harder than I would have guessed to even prototype solutions for that. I still think it's doable, and I think there's a decent chance that we'll just keep, in our same pattern of every few months someone will go hack on it for a couple of days, and like that one of those times it'll work. I've seen the show enough times to know that kind of thing can work. But it's notable how frustrating it's been from that perspective, and then even more probably the performance of it is bad and hard to usually almost anywhere in Urbit. If something's slow, you can just look at it and be like, if you spend a few hours digging into it, you'll see that it's that you can speed it up 2x, 5x, 10x by stopping it from doing it's doing the same thing over and over and over, or it's in one case it was reading from a virtual file system every time we addressed another 16 kilobytes of memory, right? Like it's doing absurd stuff that if you just look at it for a little bit, you'll figure out what it is, and then you can fix it. And with the Hoon compiler, it has been fairly resistant to that kind of analysis, in part because, when you look at it, this is probably true of compilers in general to some extent, but if it's very difficult to look at it and be like, well, it's spending this much time compiling wet gates. Is that because compiling wet gates is slow, or because it's compiling too many wet gates? And that's spending, and you can see, okay, well, within wet gates, actually within the whole thing, it spends a lot of time on name resolution. Is that because name resolution is too slow, or because it's resolving too many names? And you do this just for every part of the system, or every part of the compiler. And it's difficult to get good answers on that. And it may need more focused work. I don't know. Every few months, I go and try to make the Hoon compiler fast, and only a couple times have I made any significant difference there. Some of the big ones just being cache management, making sure your caches don't get huge. But the compiler itself, the logic there, I don't know. It's just been intransigent.
Yeah, I agree. It feels like that's the part of the kernel that we have sort of the least control over, the least ability to just kind of change, throw out, redo.
Yeah.
All right. Next question from Quad. Is a protocol for data streaming somewhere on the roadmap? Something for a native internet radio, broadcast, or video calls? Well, I don't know if it's officially on the roadmap, but it's definitely been discussed. And I'm somewhat partial to the idea of being able to use the Scry namespace for this, where I think that ideally, whether the source or the destination of a stream of data like whether that's live or like whether that's ephemeral or persistent, sort of each side should be able to determine ideally. And so, for live streaming of a video like this, if you're not recording it, then you don't want it to be persistent on the device that's streaming it. But somebody watching it might want to record it, or they might not want to. They might just want to stream it and then throw the frames away. So I think ideally you could have just sort of some consistent, basically naming system for the different frames of a video, or the data that can be used to reconstruct those frames, and then and so I think placing those within the scry namespace would be very nice, of course, and would provide a sort of unifying idea for how those different things could work. There are some issues with that. One is that you would have to support data being able to come into the scry namespace from outside of an Arvo itself. And Arvo would presumably provision some other process and say, yeah, this camera is allowed to push frames into the namespace. There's some debate as to whether that's kosher or desirable. But I think that eventually, yeah, we should have something like that. The alternative looks something like leaning more heavily on WebRTC for streaming protocols, which I also think we should do in the short term. We've had some brief discussion on Twitter lately about maybe we should bundle like a WebRTC relay server called a stun server, return, I can't remember the name, but it's there's a relay server that's used for WebRTC. We had the option of bundling that into Ver, or if it's runtime if we want to, probably. So that's something to look into potentially as a way of sort of, okay, we don't have a native Urbit protocol for streaming, but at least your Urbit considered broadly as the code that's running on your computer that deals with Urbit would be able to handle streaming. But that's my answer. I'm curious if other people have their thoughts there.
Yeah, the WebRTC case you mentioned immediately came to mind when I read this question. I know there was some discussion some time ago also about like replacing the current implementation of AIR's channel system, which currently goes over the service and events protocol, replacing that with something different like WebSockets, or indeed as was suggested later, WebRTC, and those might go hand in hand if it came down to that.
Yeah, I think this is, similar, if smaller scope to the gaming question, actually. And there's a series of waypoints along the way where the eventual destination is absolutely, fully native Urbit, full speed, media broadcast, multicast. But there's lots of things that can be done in the intervening period to make it easier to set those things up or distribute them, give you some more control, put the metadata in your Urbit. And these prototypes have been done here. Edward Amsden did some. Holium has done work in this regard. And I definitely think we should look into some more official, core level support for these things.
I mean,
yeah, notably, and potentially different from the gaming case, it is like with remote scry even now, it is already much cheaper to send the same data to many people than you would expect just by naively, if you want to send 10 megabytes to one person, that costs 1 unit. Sending it to 10,000 people used to cost 10,000 units. And with remote scry, now that costs, realistically, like a few units. It's not very much. And so for something like internet radio broadcast, something like that, that may become like we are certainly building things with the expectation that that kind of thing, that kind of broadcast of the same data should be relatively cheap and like scale really well.
I'm going to skip around here within the questions here. I was going in order, but there's one near the end that I want us to hit. From John Franklin. Will dynamically installable jets ever be possible?
Short answer, absolutely.
Yeah, it like that requires more than anything else in the system. Almost that requires a very strong permissions system, basically, because if you're installing a jet, you need to one way or another make sure that it can't pwn like the underlying system. One of the ways of doing that is to run installable jets inside of a sandbox, and maybe eventually all jets, maybe run it within WASM or something like that. That's probably going to be the correct answer. But even otherwise, a jet is certainly able to violate knock in a way that could make it difficult to keep your ship working correctly across updates. And we can do a good amount to mitigate that. For example, every time a jet changes, well, I don't know. Yeah, there's a few things that we could do to try to mitigate that, but I'm not sure they'll be able to eliminate it completely. And so we need to somehow be able to communicate to people clearly. Basically, you're installing something that could compromise your ship's ability to continue, which is on some level not that different from installing something that's able to write to your hoon.hoon file, right? If it can change your operating system, it can compromise the ability of your Urbit to continue, really. But it's still a challenging product problem.
All right, we've got a question from Jack Fox. What's the future of docs and/or Urbit Markdown? I guess docs, you mean like udon, or maybe you meant doc strings. As for udon, I would very much like to delete that.
Rest in peace.
Yeah. I don't know if anybody wants to not delete it.
I don't know. There's an argument to be made for it, but it probably shouldn't be a core thing. It's too. I mean, clearly it's too contentious for that.
Well, let me get out way over my skis here, and talk about experimental work and the way I would think about this. So there's a bunch of things that are in Hoon proper that could be characterized as DSLs. And then there are also a bunch of things that get wrapped around Hoon proper that could also be characterized as DSLs. And these are done in inconsistent ways. So an example would be sail. Sail is a DSL in Hoon for, depending on your perspective, XML or HTML data, or some, relationship to either of those things. Not clear that it's strictly a subset. And it's cool, but it doesn't belong in a Bootstrap compiler, right? And then, over on the other end of the spectrum, you have Dojo syntax, which extends and actually, kind of shadows and clobbers Hoon syntax in a number of different ways. But it does it from the outside, right? So there's all of these syntactical constructs that you can use at the top level of a Dojo expression, but then inside of those, you go into a Hoon context and you can't use Dojo syntax anymore. And this is high friction. Excuse me. Even more trivially, the Ford runes you use to import files in user space get wrapped around Hoon syntax. And all of these are kind of part of the language, kind of not. They're kind of their own DSL. They're kind of not. And I would like to see a systematic way for, first of all, building DLs in Hoon, and second of all, enriching Hoon with additional syntax. And there's actually some experiments going on with alternative parser designs that would allow this sort of thing in a fairly rigorous way. I think they're too early to characterize concretely, but you can conceptualize parameterizing the Hoon parser with additional syntactic constructs, parameterizing the desugaring, the macro expansion that happens in the Hoon compiler, to translate those constructs into the base language. And then if we did that, we could actually delete a bunch of things from the base language that are not needed in a Bootstrap compiler. You don't use sail to bootstrap, the compiler itself or the kernel. Getting a little more speculative, you actually don't use floating point to bootstrap the compiler or the Arvo kernel. And so if we had such a facility, it would open up interesting possibilities of layering within the language itself. I actually think that Udon is a pretty good idea, in contrast to some other people. The execution leaves a lot to be desired. But it clearly has no place being in the Bootstrap compiler.
Yeah, to make the Hoon syntax extensible in that way, and to make it extensible recursively, right, where you could have a new Hoon that includes other Hoons that include the new Hoon. My understanding is that you need a recursion scheme for this, right? Maybe that's the wrong term, but you at least need a fixed point data type here, right? Where you say, instead of defining, the Hoon AST data type as saying, it's either, instead of defining it recursively, where you say, if it's a, a Tizlost and it has, a P field and a Q field, which are both Hoons. Instead, you parameterize the Hoon AST data type on the sub-Hoon data type. And then you say this thing contains a P, which is a sub-Hoon, and a Q, which is a sub-Hoon. And then to make the actual data type, you have to pass that into itself to make a fixed point, sort of like a Y Combinator, but for types.
Right.
That's the way we would do that, right? If we took this approach.
I think so. But it's too early, they're just experiments, man.
Yeah. Okay. Here's a question from Sage that's interesting. Thinking about distributing apps by way of Scry, what might user analytics look like if data is read-only? Yeah, I would say this is a general problem, right? Like, it's not just distributing apps, but if you want to run a blog or something and track how many people, visit your blog, there's in general a tension between, getting notified and having to do a disk write every time somebody tries to do a read, which is sort of how you might naively do this. Say, well, every time the user, reads the data, you write that to disk and you increment a counter. There's a tension between doing that and then having it be performant, because what you really want is not to do a disk write every time somebody loads a website. So I think what I would do here is something like have a counter in var that's not written to disk, and then occasionally, maybe on a timer, or if the counter reaches a certain number, have var inject an event into Arvo saying, hey, you just got another 1,000 reads on your site. Or in the last hour, you got 12 reads on your site. But I don't know how to make that extensible, right? Some sort of general purpose functionality that Arvo can ask var to do for it, which is, I think, what you would want.
Well, and it's a harder problem than that, because Remote Sky right now is only cached in your own runtime, but at some point that'll be cached in other intermediaries. Potentially your sponsor might cache. Now, okay, maybe your sponsor can keep track of these things, but also it's very possible. Like I would not be surprised if Tlon as a hosting provider puts makes our own Scry cache just for popular groups that would say, oh, a lot of people ask these things, and so we're going to do those, on behalf of these other ships across the network, sort of, but really it's just because we want it to be faster for our users, and we don't have any relationship with these other people, and so, like, are we going to report user data to them? it like that becomes impossible to enforce. And so I think that what you'll like, so one answer to this is basically that you have like whatever user data that should be sent gets sent explicitly. And this has some really nice properties, right? So what I mean by that is like right now when you install Talk, which is installed in everyone's ship pretty much, right? When you open it up the first time, it'll ask you, do you want to send some information to Tlon? And it's, essentially it tells us, I forget the details, but it tells us more or less, like it says not like exactly when you're using Talk or whatever, but it tells us we're trying to get like monthly or daily active users, something like that. And so it gives us, you used it at least once over this period of time, something like that. That's just, the app on your ship sending that. And we give a way to not send that by just clicking decline there. But you could also, obviously, it's your own app sending it. You could just change the app to not send it, even if we didn't provide a way to do that. And so it's always going to be somewhat optional. But then it can be exactly only the information that you've decided to intentionally send. And it makes the whole thing more explicit and more performant. And on some level, and in terms of the accuracy of the numbers, the question of how often, like when you look at how often does a program get downloaded from a website, does that correspond to users in some meaningful way? There's some positive correlation, but it is not one. And so in this regime, there's a different, the ratio between the numbers you have and the numbers of actual users is going to be different. And in particular, it's going to be that you have more users than responses. Whereas downloads from website, usually you have less users than downloads. But you can still do useful stuff based on that. I mean, as I understand it, unless I'm totally wrong, the entire rating system for TV and stuff is based on, very few responses from write-in mailers and stuff. And I mean, they have other ways of detecting things, right? If you're trying to evaluate how effective are your ads, the people doing the ads can determine that for themselves by seeing, okay, what happened to our sales in that area and whatnot. But that system, there are existing systems that work in this kind of environment when you can't recognize every download. And I think we'll end up looking more like those.
Yeah, I think it's interesting how that wasn't the way this works out for analytics wasn't ever part of the design or implementation intent of remote scribe, but it sort of falls out of it naturally. Certainly if you combine this with something like user space permissions, where it's like, hey, I'm installing your app and I scry that out, and so you don't even know I'm installing it. And then when the app starts up, it's like, oh, I need permission to talk to other ships, even though it's like a single player note-taking application, right? Then there's the option for me as the user to say oh, I do want to, let you talk to other ships so you can ship the telemetry back and forth, or I want to, not let you do that. And so you end up with a lot more user control of oh, do I continue in stealth mode or actively share this information with the developer.
All right, let's do a little change of pace here. Last question from Sebastian Marshall. How would we keep apps exclusive to planets within our star? My guess would be using NFT auth via minting only L1 planets.
It depends on how much enforcement you want to have, right? There's a difference between bookkeeping and enforcement. And NFTs are never going to enforce this. I believe literally the only way they could is if you had an actual device, that's the only way that you could use it. But similar to how DVDs work, right, where there's chips in there that enforce the DRM, and that's never going to happen. You can because basically, if someone downloads an app, they could just repost it to somewhere else. And so the only way to really enforce this is going to be if the star is itself providing some service that you need, right? If you have an app that what it does is it asks the star, do XYZ, right? Mirror this for me. That you can keep to only plans within your star, because they have to talk to you to do what the app is doing. But something more generic, I don't see a real way to do that on an enforcement level.
All right. Well, this is we're just about at time, so I'm gonna wrap this up. And if you want to keep talking, there's going to be a link to Urbit's GatherTown instance. It's going to be dropped in the chat here, and so you can go and jump into GatherTown at the Urbit Hacker House. There's a link right there, and so yeah, feel free to continue to hang out and discuss. And thank you all for the questions.
Yeah, thanks for tuning in, everyone. See you next time.
It's just fun.